Hi, my name is Morgan Smith, and this is my Project 1 for Introduction to Educational and Psychological Measurement. I am taking this course as a requirement, but also to learn more about the processes behind the testing that we do with our students. Um, Hi, my name is Morgan Smith, and this is Okay, so for our first point, we're going to talk about measures of central tendency. So when we have descriptive statistics, it's an analysis of a set of quantitative, which is numerical data, and we can kind of use it to look at patterns. And so if you're reading article review, the descriptive statistics might save you time of reading through large amounts of data. So for education, it's really important to kind of understand and be able to interpret the data that is included in things that we might have to read or study, or when we're reviewing testing results. So the measures of central tendency are examples of the data sets, and then they depict like an overall central trend. And then there are three key measures. The first is the mean, and so the mean is just the average of the numbers. And so like when we think of average, kind of typically we usually think of the mean. And so you add all the scores together, and then you divide them by the total number of scores. And so it's valuable in testing because it takes all of the data into account, and then it's kind of the basis or can be the basis for further statistical calculations. The second thing we want to look at is the median. And so the median is the middle value. And so you have to put the numbers in order. It can either be ascending or descending. And it is the halfway point, so it separates the lower from the higher, or the higher from the lower. And it can be helpful in testing because it can kind of show us if there is an extremely high or low grouping of scores, because that can lead to a misleading average. So the last measure of central tendency is the mode. And the mode is the most frequently occurring value in the set of numbers. And you can have more than one mode. If you have 330s and 360s, that would be the two modes. And so it can be useful in testing as well. Okay, so if you look at the image, on the right side, that's kind of showing our measures of central tendency. And then on the left, you'll see in the blue, there's a thing called dispersion. So dispersion is, it's showing the it's giving an indication of the spread of the scores. So the extent to that scores deviate from the measure of central tendency. So first we have the range, and the range is just the difference between the highest and the lowest score. It's fairly easy to calculate, and it kind of takes into account some of those extreme values. The next thing we have to look at is the variance. And to find the variance, it's the average of the squared differences from the means. And so basically the variance is just a way to see how the individual numbers relate to each other within the data set. And it can also help determine the size of the spread. And then the last thing in the dispersion is standard deviation. And standard deviation takes into account all of the scores, and it calculates the average distance from the mean of all the scores. So it's very powerful when we're looking at dispersion. It's more fine-tuned than the range, because the range is just the highest or the lowest, but with standard deviation, it's all of the scores are being considered. So that's important when we're reviewing testing results. Okay, so now we're going to talk about measurement and measurement scales. So first, just the definition of measurement. It's the assignment of values to objects according to some system of rules. And so you have to have three things for measurement to happen. You have to have an object, a variable, and values or units. So the four types of measurement scales fall under two different categories or variables. So first you have quantitative. And quantitative means it can be counted, like the number of people per square mile. Qualitative is a description or labels, so like a brown dog's fur. Sorry. Okay, so first let's look at qualitative and the two types of scales that fall under that variable. So first we have nominal. And so nominal scales are used for just labeling the variables. They don't have any quantitative values. So when you think nominal, think label. So an example, what is your gender? What is your hair color? Where do you live? So we don't have the central tendency for nominal would just be the mode. They can't be arranged in any particular order. So remember, nominal is qualitative and it's labels. So the second type under qualitative is ordinal. So ordinal, think order. So the order of the values is what's really important in ordinal scales. So like the difference between okay and unhappy, can we say that's the same as the difference between very happy and happy? We can't really. So ordinal scales are measuring non-numeric, again, it's qualitative, concepts typically like satisfaction, happiness, discomfort would be some examples. So remember, ordinal, order. And so for central tendency, tying it back to that, with ordinal data, you can use mode or median, but not mean. So again, it's kind of like our type scales. How do you feel today? How satisfied? And you could do, 1 to 5 or agree, disagree, neutral, things like that. And so with ordinal data, we also can have comparisons and orderings. Okay, so that was qualitative. So nominal, ordinal. For quantitative, there's, again, two different scales. So we have, first is interval. So remember, quantitative you can count. So, or it has numerical values. So with interval scales, are there numeric scales in which we know the order and the exact differences between the value. So that's what's important about interval, is they have meaningful differences between the value. So an example of an interval scale would be Celsius or Fahrenheit. There's a difference between 60 and 50 degrees. It's measurable by 10 degrees, and that's the same difference between 70 and 80. So typically when we're at the interval, we're just using addition and subtraction. And for measures of central tendency, you can do the mean, median, and mode. So interval is measuring a set interval between numbers. Okay, so then the last type of scale is ratios. So ratios are kind of the top of the measurement scales because they can tell us about order, they can tell us about the exact value between units, and they're the only type of scale that has an absolute zero. So an absolute zero means that there's nothing at all. So like if a person took a math test and scored a 0, that wouldn't necessarily be a ratio scale because that doesn't mean they don't have any math ability whatsoever. It was just maybe they didn't understand that particular set of problems. So remember, absolute 0 means there's no ability at all. So for ratio, examples could be height and weight. And so central tendency for ratio, it can be measured by mode, median, or mean. And then you can have measures of dispersion like we talked about previously. You can have standard deviation and then variation as well. So these are the 4 types of scales, and they fall under qualitative, which is your nominal and ordinal, and then quantitative, which is your interval and ratio. Okay, so now we're going to talk about scoring. So we're going to talk about standardized test scores. And so there's many different types of test scores that we're going to talk about that can be used in educational testing. But first I want to just talk quickly about the raw scale score. So a raw score is just a score that doesn't have any sort of adjustment or transformation. It's just simply the number of questions that were answered correctly. So that in the Enghoff text, he notes that the raw score scale, it doesn't always have the given value doesn't always have the same meaning or representation of the level of ability. And so essentially raw score scales are just scales that don't have any inherent meaning, and they cannot be interpreted without some sort of supporting data. So the next type of score I want to talk about is standard scores. And so standard scores are used to interpret and compare raw scores. And so you're looking at the standard deviation, and then you're kind of taking the statistical average based on the performance of the students tested in the norming process. And we'll talk more about norming later, but that score is then assigned a value. And then the standard deviations are used to determine what scores fall within the above average, average, and then below average. So the next one I want to talk about is percentiles. And so percentiles just show how, in regards to educational testing, maybe how that student's performance compares to the others who were tested during the test and development. So you might hear something referred, he's reading, or his fluency is in the 50th percentile. So that means he performed at least as well as 50% of students his age. Then you have z-scores, and z-scores, so the rest of the scores are going to actually fall under the standard scores. So z-scores describe the position of the raw score in terms of its distance from the mean, and it's measured in the standard deviation units. And so if the z-score is positive, that means the value is going to lie above the mean, and if it's negative, it'll lie below the mean. Again, it is a standard score. Then you have t-scores, and then these range, and so these are all can be seen on the Gaussian or the bell curve. And so the t-scores range in intervals of 10 to 90 points, and then 50 is the average on the scale. Then you have the STAY-9 score, and it's also called the Standard 9 score, and then these scores range from 1 to 9, and then 5 is the average. So if you score below a 5, you're below average. If you're above a 5, you're above average. Then you have scaled scores, and these just involve presenting different scores on a number of subtests, and they could represent a specific skill or area. So that is our discussion on the different types of standardized scores. And again, the Z, T, STAY-9, and scaled fall under standard scores, and then percentiles are separate. Okay, so now we're going to talk about norms. So I want to talk about the three main purposes first. So the first main purpose is that when developing the tests, the publishers use the normative data to help us have a familiarity with the scale for the test. The second main purpose is it allows us to acquire an understanding of the dimensions for the major subgroups of the population, how they differ, and then the degree to which the variable of the test is associated with classifications of the population. And the third main purpose is it allows us to take the outcomes of the level of the performance of the individual of the group, and then we can make informed, data-driven decisions for action. There are several generalizations that are appropriate to the construction of norms. The first is the characteristic that's being measured by the test. It has to permit the ordering of the individuals along a transitive asymmetric continuum from low to high. So if we go back to our measurement scales, it has to be ordinal at least. The second generalization is that it must represent. So for the second generalization, we have to have a reasonable operational definition. An operational definition is just how the test is going to happen and what it is testing. So we have to make sure that all the tests are intended to measure the characteristic will yield some similar ordering of the individuals. The third generalization is the test must provide an evaluation of the same psychological characteristic. It has to be consistent throughout the range of the scores. The fourth generalization is that we have to choose an appropriate population. So if the norm group is third graders, you wouldn't test 12th graders to be the norms group. However, that being said, appropriateness can be hard to define and keep separate from the concept of difficulty. The fifth generalization is that the data should be made available for as many of the distinct norm populations as there are populations with which it's useful for an individual or a group to be compared. And this is also taken from the Enghoff text. The sixth generalization has to do with the items of the test itself, that they should be selected on the basis of data, and that it should be drawn from the population for which the test is intended. So those are the 6 generalizations that we should keep in mind when we're constructing these norms. Okay, so just like we just talked about, norm reference standards are used to judge an individual's performance in relation to the performance of other members of a well-defined population. The standards are valuable to compare among individuals, and scores from testing can be interpreted in 2 ways. The first way, which is what we're talking about, is norm referencing. And norm referencing is just the way to compare, like I said already, the test score with the score of a specific population. And then that's known as norm referencing. And then the second way you can interpret a test score is criterion referencing. And you establish an external criterion, and then you compare the test score to that. And then that process is known as criterion referenced testing. Okay, so there's several different types of norms. So first, we have age equivalent norms. And then these norms are defined as the average performance of the sample of a certain age level. And it's usually measured by trait or ability. And age norms are usually most suited to traits that increase systematically with age, like intelligence. So the second type is grade equivalent norms. And then these norms are the average performance of a representative sample of a certain grade or class. And then to find grade equivalent norms, you compute the mean raw score obtained in each grade, and it's kind of like the average number of problems solved correctly on a test could be then used to compute the grade equivalent norm. So age and grade equivalents do have limitations. And then when we're talking about normative groups, there's 2 different types. We have the single reference group, which is exemplified by the percentile distribution and normative scale distribution. And then the second type of group is the mean scores of a series of reference groups. And that can be exemplified by age equivalent. So some examples might be subject matter achievement tests or intelligence tests for the mean scores. So within group norm, we have the percentiles, and then we have standard score norms. And percentiles we talked about in scoring previously, but they're expressed in terms of the percentage of persons in the sample size. And it can represent the relative position to the standardized sample. Percentiles are different from percentage scores because the percentage scores are the raw scores, like he scored 98%. So they're expressed in terms of correct items. And then percentiles are derived scores. And then they are expressed in terms of percentage of a person. So then the second is standard score norms. And then the standard scores express the person who's being evaluated, their distance from the mean. So we think standard deviation. The standard score is the derived score, and we talked about all the different types of standard scores, the Z-score, T-score, Stay9, all of those in a previous slide. But those are the norms that they're being compared to. Last, I just want to touch on the two different types of norms. So we have national and local. National is the most general used and most commonly used types of norms. And then we have a local, which is usually the test publisher has to go and they kind of make appropriate they collect their local norms. And this comes up actually interesting in my school. We have a 99% pass rate on the STAR test. And so a lot of times teachers will refer students to special ed thinking, oh, they're behind. But then when we do the testing nationally, they're really not behind. So that's kind of an example of like local versus national. Okay, so now we're going to discuss the different frameworks that we can view the test through. So item analysis provides us a way of measuring the quality of the questions. We want to see how appropriate they were for the respondents, and then also how well they measured the ability or trait that they were measuring. And so there are two theories that we're going to talk about that kind of fall under the item analysis. First, we have the classical test theory, and then we have latent trait models, and then under that model is item response theory, and then the RASH models. We're just going to focus on classical test theory, or CTT, and item response theory, IRT. Okay, so classical test theory, the analyses are the easiest and most widely used with this form. The classical analyses are performed on the test as a whole rather than like on item by item. So every measurement is comprised of two components. You have the true ability plus random error equals observed score. And like I said, this is the simplest framework. And then so the true score is not the same thing as an ability or trait. We'll discuss that under IRT. And it's an estimated measurement. It's not measured directly. So errors are assumed to be random and not systematic. And then the correlation between two reliable parallel tests. So again, this is a simple way of measurement. It's the foundation of reliability. And the true score theory can be used in computer simulations that generate observed scores with certain known properties. So again, this is the true score model. We assume that the error is normally distributed, it's uncorrelated with true score, and it has a mean of 0. Okay, so then the latent trait model, specifically we're going to be looking at the IRT. They aim to kind of look beyond that, and they look at the underlying traits, which are producing the test performance. And so they are measured at item level and then provide a sample-free measurement. So for the item response theory, it refers to the family of latent trait models, and it's used to establish properties of items and scales. And item response theory is sometimes referred to as modern psychometrics because it has the large-scale education assessment and testing programs. And today, IRT has almost completely replaced CTT, and it has a lot of advantages, which is why it's been brought into more frequent use. These are just kind of a brief overview of the two frameworks behind item analysis. Okay, so now we're going to talk about linking and equating. So a lot of the large-scale assessment programs often have more than one test form. Like, for example, I'm Wilson Reading Program certified, and we have two forms that we use. We have Form 1 and Form 2. So we give one at the beginning of the year and one at the end of the year. So equating is a really important factor in evaluating the validity of the assessment. It's a very technical procedure or process, and it's conducted to establish comparable scores that have equivalent meaning or different versions of the test forms that are the same tests, and then they can be used interchangeably. So equating is often misunderstood or used inappropriately. So we're going to kind of dive into more of what equating is in a minute, but first I want to talk about linking. So linking is the practice of pairing or matching scores on two test forms with no strong claim that the paired scores have the same substantive meaning. And this is from the practitioner's introduction to equating, that definition. Okay, so linking, it's different from equating, and it doesn't have the same interpretations that are supported by equating, but they use some of the same procedures. So in both of the linking and equating, the scores on one form of the test are matched or paired to the scores of the other test form. So you can have your standardized norm reference test can be linked to a standards-based assessment. Now, linking, there is a continuum, and so equating asserts a strong association between the scores, and equating is kind of the strongest form of linking on the linking continuum. So equating, so we use multiple forms of the test to ensure the validity of scores. So like I mentioned a second ago, we can't give the same test, or it's not going to be as valid if you give the exact same test, to have multiple attempts. It's not going to give you the same validity. And to assess growth or change, we have to test students several times over time. And so that's where equating can come in. And so we want to have not the exact same test, but something that's testing the same thing. So the different test forms are intended to measure the same skills, and they need to be of similar difficulty and discrimination. So we're measuring the same constructs. So that means they have the same mean, variance, reliability, and correlations, and then the test can be said to be parallel. So if test forms were actually truly parallel, then we wouldn't need equating, but they're going to differ somewhat. So that's why we have to take into account that they could be a little bit different, and that's why we need to equate. So if we are successful in equating, it will result in scores that can be compared with validity, even though they are different test forms. So kind of a principle of equating is it should be equitable, and equating happens during the creation of the test. also going back to our classical test theory, so if we equate under the classical testing theory, we would create a table for converting raw scores on one test to the scale of the raw scores on the other test. However, doing it under this framework lacks a strong theoretical basis. When equating, it's stronger to use the IRT model over the CCT model. It's more of a mathematical model. Okay, the last thing I want to talk about is equating versus calibration. So, like I mentioned in the previous slide, that there is the linking continuum, and equating has the most strict requirements for equivalence, and then less equivalent conditions involve calibration. And so, in calibration, tests are compared that measure the same construct. So we're still measuring the same construct, but in calibration, they can vary in design or difficulty. And so you can compare and moderation, and that compares tests that measure different constructs. Calibration, like I said, equating is used during test development, and calibration happens after test development. So again, they still measure the same construct, but they have unequal difficulty. Okay, that was the end of our discussion on the measures of central tendency, measurement scores and scaling, norms, and equating and calibration. Thank you so much for listening.